Our next set of examples here are a little bit more complicated. Again, if you're not sure what to do with the number, for example 4, we have the 4th root of 64, c to the 10th, d to the 15th. We could do our factor tree for 64. So 64 is divisible by 2, and we get 32. And 32 is also divisible by 2, that's 16. Which is also divisible by 2, is 2 and 8. Which is also divisible by 2, that's 2 and 4. Also divisible, that's 2 and 2. So if we add up again all of those dead branches, we know that 64 is 2 to the 6th. So we can rewrite it that way. So 64 is 2 to the 6th. You still have c to the 10th, and then d to the 15th. So again, one way to do this is to ask yourself, how many times does the 4 go into 6? And so the answer is it goes in there once, and you have 2 left over. Then again, you would ask yourself, how many times does the 4 go into 10? And that answer is 2, with again 2 left over. Then ask yourself, how many times does that 4 go into 15? And that would be 3. And this time we have 3 left over. So since we're dealing with an even root, we should put those variables in absolute value signs and go ahead and simplify this a little bit. So we'll have 2 times the absolute value of c squared d cubed times the 4th root of 4c squared d cubed. We can do the same thing for example 5. We can take 128 and do our factor tree, so that's 2 and 64. But instead of continuing this, we already did the factor tree of 64 over here, so we know that that's 2 to the 6th. So 128 must be 2 to the 7th. We have e cubed, f to the 12th, g to the 25th. So you can do the same process we did for example 4, or we know that from example 2, when the index and the exponent match, that's when your quantity is able to come outside the radical. So what we could do is rewrite the things underneath the radical. So 2 to the 7th, we could rewrite as 2 to the 5th times 2 squared. Remember that when you multiply, you add the exponents together. For f to the 12th, we could rewrite that as f to the 5th times f to the 5th times f squared. That adds up to 12. For g to the 25th, we could do g to the 5th times 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 g to the 5th. So once you have it written out that way, it's a lot easier to see which ones match the index. So what I've told my kids before is that the 5 out here, the index, that is the jail keeper, and everybody else in here is in the jail. And when you leave jail, you don't want to wear your stripes when you go outside, so you're going to leave your little exponent with the index since they match, or the jail keeper. So only the variables or numbers with the little 5s in the exponent position are allowed to come outside. Everyone else is stuck inside. So 1, 2 gets to come out. There's 2 F's that get to come out, and 5 G's that get to come out. And the rest are stuck underneath there. The 2 squared, which is 4, and the F squared. So if that helps you, go with it. If not, then you can go back and use one of the other methods. I see I forgot the E up there. You have E cubed, but 3 is less than 5, so that guy is stuck underneath there as well.